Okay, so we have this equation and we must find the domain for it. So we have the square root of 432x to the fifth minus 675x cubed minus 128x squared plus 200 divided by the square root of 7x to the 8th plus 35x to the 7th minus 93x to the 6th plus 25x to the 5th minus 70x to the 4th. And we are given that for the numerator we should use 16x squared minus 25, and for the denominator x equals 2. So focusing right now just on the numerator, we know that since this is a square root, we have to find where x is equal to or greater than 0. Now we have to do this because we can't take the square root of a negative number. This is impossible since a square number is a number that is multiplied by itself, and that gives your output. Now the thing is, if you multiply a positive number by itself, you will get another positive. If you multiply a negative number by itself, you get a negative. And that shows where you can't get a negative output for a square number. You can't take a positive number, multiply by its opposite in a negative form, because they aren't the same number. It just does not work that way. And so it only works if the output for x is a positive output. Now, so we'll long divide this since we are given 16x squared minus 20. Okay, I'd like to apologize for earlier. My camera ran out of memory space. So as I was saying, we bring down that negative 32x and bring down the negative 40. And so we take negative 32 divided by 4, giving us negative 32 divided by 4, giving us negative 8. And so negative 8 times 5 is negative 40. So we have negative 32x minus 40. And those cancel out. So now we have left overall, we have the solutions 4x minus 5, 4x plus 5, and 27x cubed minus 8. Yet we aren't done. Since this, as you can see, both the 27x cubed and the 8 are cubed numbers. So that means that by using the difference of cubes, we can simplify this further. So now 3 and x are the cubed roots of 27. So we put 3x, and 2 is the cube of 8. So minus 2. And now over here what we do is we put the 3x squared. So we'll have 9x squared. Plus, now we multiply the 3x by a 2, giving us 6x. And now we square root the 2, giving us 4. And so our final solutions will be 4x minus 5, 4x plus 5, 3x minus 2, 9x squared plus 6x plus 4. Now, it's good to note that we were told in our class, and this term, that this quadratic equation that you get from the difference of cubes, or even if you got it from a sum of cubes, it is very unlikely it will ever factor farther, and for our purposes we were told that just never consider they will factor farther. So I'm not even going to mess with that. But it is good to note that so now we must find the domain. So to find the domain, we first have to look at like what a general picture of this graph would be. And to do that, we check the highest exponent of the term, and we judge from there. So since the a value is a positive number, and the highest term is a 5, we know that it will start negative, go positive. Oh, I'm sorry about that. My camera had shut down. But what I had been saying is that you could figure this out with your calculator, but my calculator is actually having a little difficulties right now. But what's simplest is that 7x to the 6th plus 5x to the 4th. Since there's no other values in there except for x to the 4th and x to the 6th, we can determine that those will only bounce at the 0, and they actually bounce at 0 at the x-intercept of 0. But they go through 0 since it's just x to the 6th. Whether it doesn't matter the coefficient above that, but since it's only x with a coefficient x times something, it's still really just x, and it'll go through 0 no matter what. There's no value to move that, shift that left or right. Now, from that, we can tell that the graph actually would look a lot like this, and these values